Hello and welcome to my channel. I am Mensa Justin. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you are not yet subscribed, please kindly subscribe for us to grow the mathematics community. In this lesson, we'll be looking at this question. Thanks to Ebenezer Boham from University of Ghana, Legon, for sending me this question. If y equal to, into bracket, the inverse sine of x squared, prove that, into bracket, 1 minus x squared times the squared y on the x squared minus x times dy on the x equal to 2. Join me as we prove this within some minutes. Okay, so this one is a composite function. So we take u to be equal to, we are doing u substitution, the inverse sine of x. This implies that y equals u squared. The derivative of y with respect to u equals 2u, which is equal to 2 times the inverse sine of x. And here, the derivative of u with respect to x equals derivative of the inverse sine of x with respect to x, which is equal to 1 divided by square root of 1 minus x squared. Now, the derivative of y with respect to x is equal to the derivative of u with respect to x times the derivative of y with respect to u times the derivative of u with respect to x, which is 2 times the inverse sine of x times 1 divided by square root of 1 minus x squared. And that is 2 divided by square root of 1 minus x squared as dy on dx. But here we have the second derivative, so let's do the second derivative. Now, to do this one, don't worry yourself using the quotient tool. Just clear the denominator. Simple. So let's clear the denominator. So, to clear the denominator, we have square root of 1 minus x squared dy on dx equal to 2 times the inverse sine of x. Just multiply here by square root of 1 minus x squared and multiply here by square root of 1 minus x squared. So that this one we'll cancel this and we have this one here. That is what I've done. Now, we are going to differentiate this and then differentiate this to get the second derivative. But here, remember that we are going to use the product rule because we have this and that. So here, we are going to have dy on dx times the derivative of square root of 1 minus x squared with respect to x plus square root of 1 minus x squared times the derivative of dy on dx with respect to x equal to 2 times the derivative of the inverse sine of x. With respect to x. Now, how do we differentiate this one? For, let's say, v equal to square root of 1 minus x squared. This is what we are going to differentiate. We have v equal to 1 minus x squared to the power half. We have dv on dx to be equal to half of minus 2x times 1 minus x squared to the power negative 1 out of 2. How do we do this? Bring the power here, differentiate the inner one, and multiply it by the power. Then take the original function and subtract 1 from the power. That's what we have here. Subtract 1 from this, we get this. So this will cancel this. We have minus x. Here we have x to the power negative. So we can take 1 minus x squared down and bring power positive. Very simple as that. So here we are going to have minus x divided by power half is the same as square root. Square root of 1 minus x squared times dy on dx. We have dy on dx here, and we've differentiated this one. So plus the derivative of dy dx with respect to x will give us d²y on the x squared times 1 minus x squared under the square root equal to 2 times. If we differentiate the inverse sign of x, we are going to get 1 divided by square root of 1 minus x squared. So check the description for my video on how to differentiate using the chain rule, and you understand these basic derivatives. Now, here the question is almost solved. Why? Because we can multiply 2 by the denominator, that is square root of 1 minus x squared. We multiply here by square root of 1 minus x squared. We multiply here by square root of 1 minus x squared. And then you multiply here by square root of 1 minus x squared. And here this one, since you are multiplying, this one will cancel this. So it will be left with minus x, the derivative of y with respect to x. Now, if we are multiplying this, we are going to have plus 1 minus x squared dy on dx. Check y. We are multiplying this. It is square root of 1 minus x squared times square root of 1 minus x squared. So it will be 1 minus x squared all squared under the square root. So this will cancel that. And this one too, this will cancel this, and we are going to have here to equal to 2. I hope the question is solved. Just left with rearrangement. So here we have 1 minus x squared times dy on dx minus x times, oh, this is d squared. D squared y on dx squared minus x dy on dx is equal to 2. That is to be shown. We have 1 minus x squared d squared y on dx squared minus x dy dx equal to 2. So that is that. Remember here, I multiplied 2 by the LCM. So this one is actually multiplying. This one is multiplying this. And this one is multiplying this. Thank you for watching. Please like, share, subscribe, and leave your comments. Bye-bye.